We finally get to Pluto. The discovery of Pluto is sort of similar to the discovery of Neptune in that Uranus and Neptune, they look like there was something off with them. That their orbits were not quite perfect. So again, rather than Kepler and Newton being wrong, there's got to be something else out there. So they worked to try and find it. Specifically, Percival Lowell, and you can see the initials of his name, PL, Pluto, Percival Lowell. He's like, you know what, I'm going to find this planet. So he found this planet. He calculated how big it should be. He calculated its orbit. He calculated its position. And he basically said to Tom Bogg, okay, look, here it is in the sky. Go point your telescope and see what you can find, right? Just like they did with Neptune. And Tom Bogg found it 6 degrees away from where Lowell predicted it would be. 6 degrees. That does not sound like a lot. I mean, right, a circle, 360 degrees, and he's like, okay, right there, and he was like 6 degrees off. However, a full moon's like half a degree, so, yeah, you know, kind of is a little bit off. Turns out, yeah, it was just luck. The math just happened to work out within a certain... Because Pluto is actually much too small to pull on Uranus or Neptune. And it was just the fact that Uranus and Neptune were bigger than we thought, and so their irregularities didn't actually exist. It's kind of like triumph for math and science, and then no so much. Okay, so Pluto is really hard to see, but there's a picture of it. It is 40 AUs from the sun. This is an outdated thing, but we flew by it a couple years ago. There's a picture of it. Okay, even if you have a good telescope, it's really hard to get a good picture of Pluto. So Pluto has moons. One of them is Charon. Charon is, if you compare the mass of the planet to the mass of the moon, Charon is the biggest moon there is. Okay, it's kind of hard to see him. I mean, this is why you need good resolution, right? Pluto's there, Charon's there. You wouldn't really know it unless you had a better resolution. So Charon is about 600 kilometers in radius. Charon is not the only moon, though. It also has Hydra and Nix. Like, how cool are those names, right? Hydra and Nix, and we have the moon. We really need to give the moon a good name. Just saying. Anyways, these two moons are small, 100 to 200 kilometers in diameter, and they orbit 2 times the distance of Charon. So this is a better picture, actually. Both of these are better pictures. But you can see Pluto, you can see Charon, you can see Nix, and you can see Hydra. Alright, so Plutoids and Kuiper belt objects. Plutoids. So it's hard to see things in the Kuiper belt, as you can imagine. It's kind of far out there. Pluto is actually the best observed thing in the Kuiper belt. Yes, Pluto is a Kuiper belt object. Sad. But again, as technology gets better, science gets better, blah, 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 we get better techniques, we get better discoveries, we can start seeing stuff in the Kuiper belt. And we think 25% of the Kuiper belt autoplane as Pluto. Now, you know, the rest of them are within a few degrees. It's not like they're the Oort cloud surrounding us or anything. So we think that there are way more, but we've identified 1,200 objects past Neptune. 1,200, Pluto being one of them. Most of them are 40 to 50 AU, right? So the sun, from the sun. So Pluto's kind of the inner of the Kuiper belt. And this, we think, only represents a small percentage of Kuiper belt objects. There are likely 100,000 things out there bigger than 100 kilometers across. we know of 1200. Also, we think the Kuiper belt has 100 times more mass than the asteroid belt. Think about that, right? And if you need an analogy, go to your backyard or front yard, pick up a rock. Any rock, just pick it up. Now go to your freezer and take an ice cube. Which one feels heavier? Which one feels like it has more mass? Right? Hopefully you didn't pick up a tiny little pebble, but you picked up a, fist-sized rock and a piece of ice. Which one feels heavier? Duh, the rock. Well, the rock would then have more mass. The asteroid belt is made up of the rock. The Kuiper belt is made up mainly of the ice. And we think there's 100 times more mass in the Kuiper belt than in the asteroid belt. So imagine how many things have to be out there to make that mass equal, never mind greater. Right? So these are some of the things that we think, or that we know, are in the Kuiper belt. Eris has a moon. Pluto's moons. Make, Hume, its moons. Quaoar, its moon. 2007 OR10. Orcus, its moon. Sedna. How come all these moons have really cool names and we have the moon? Again, someone has to name the moon. Alright, so Quaoar, I think I'm missing an A there. Anyway, it's 1,200 kilometers across. It's larger than Ceres. Hume and Make, 1,500, 2,000 kilometers across. And Eris is actually bigger than Pluto. And you can see a picture of Eris and its moon. Sedna, at 1,500 kilometers. Furthest known in the solar system, Sedna, and I'm sure that's changed by now. Highly elliptical orbit, 1,000 AU. The inner edge of the Oort cloud. The inner edge of the Oort cloud. We're now looking at stuff at the Oort cloud. And of course, there's more. Ta-da! Dwarf planet. This is a new category of things, right? We have planets, we have asteroids, we have meteors, we have comets, we have all this other stuff, and we've got a new classification, dwarf planet, right? In these, just some of them, these are not all of them by any means, but Pluto, Eris, Ceres, Hume, Make, right? They're all in this dwarf planet category. This is a really good video. Hopefully the link still works, about a guy talking about why we have this category dwarf planet. And I don't have it on here, but in order to be a dwarf planet, you have to orbit the sun. You have to be big enough to be round, but you also have to be big enough so that you clear out any debris in your orbit or in your path. And that's where Pluto falls short. That's why Pluto is no longer a planet, because it doesn't have enough gravity to fling stuff out of its way. Okay. Now, within this dwarf planet classification, there's something called a Plutoid. And I personally think they just called it a Plutoid for all those people that love Pluto. And they're like, you can't get rid of Pluto. It's like, well, technically we can't get rid of Pluto. It's a giant ice rock orbiting our sun. But they were upset that Pluto was no longer a planet, so they actually made the subclassification Plutoid. And basically a dwarf planet made out of ice past Neptune. And that's what Pluto is, a dwarf planet made out of ice that's past Neptune. This isn't the first time that things have been ousted as a planet, no longer classified as a planet. There used to be 11 planets. Ceres, Vesta, and Juno were all planets. Right, Ceres is now a dwarf planet. But as you make more discoveries, as science gets better, you start to fine-tune these categories, and some things just don't make it as a planet anymore. So that is rings, moons, and Plutoids.